This conference will now be recorded.
Let us continue. So we were with the variables of a class. So we have seen examples for instance variables or object level variables. Okay, where what are the places we can use to declare instance variables or object level variables and how to use them. Okay, later we have seen like static variables. They are like a class level variables. They will be common for all the instances. For all the objects, the class variables or static variables are common. Okay, next of course this is a common thing, but we can name it like a local variable. Let me show you one example to demonstrate what is local variable. Local variable means it tells us about the scope of a variable. Okay, quickly we'll write one example and you will understand what does it mean by local variable. Come on. So for example, I have a class demo. Okay, I have one method, say maybe m1. Here I have a variable called a, for example. Okay, I'll print variable a. Done. Next I'll have one more method, definition m2. I'll take one more variable, for example, maybe 200. Print b. Okay, outside of the class, if I create an object demo d dot m1, if I'm calling like this, and d dot m2, what is the output I'll get? If I run this program, local variable example, what is the output I'm going to get here in this example? I have a demo class. Inside the demo class, I have two methods, m1 and m2. Okay, in each method, I have declared one variable, and I'm just printing the variable value. That's it. Okay, I'm calling those methods from the object d. So I'll get the output like 100 and 200. That's fine, right? So if you see here, the variable a is a local variable for the method m1, and b is the local variable for m2. Its scope is within the method only. Okay, based on the scope where the variable is declared, we have to understand the scope of it. Okay, for example, if I try to print like this, print a, will it work? See, it's already giving error. Unresolved reference a. Okay, so if I run this, it will give me exception. Name is a is not defined in this scope. It's not available. Okay, that's why it is saying it doesn't know what does it mean by a. Okay, this is the concept of local variable, nothing more than that. Like if you have a variable inside class, that is local to that class only. If you have a variable in a method, that is local to that method only. Okay, if you want to use some variables across all the methods, you have to declare like a class variable or a static variable. Okay, that is the concept of local variables. Okay, hope you got some idea about variables, different ways of declaration of variables, and usage of variables. Okay, usage of those variables. Next we need to understand. So guys, if you are following me properly, we discussed about a declaration of a class. Okay, we discussed about a declaration of an object or instance. Then we know that class is a user defined data type, and it will contain members and member functions or variables and methods. Okay, we discussed about variables. Now we have to look how we can what are the different ways we can use methods. Okay, let us see types of method declarations. Okay, types of methods in a class. Let us see. Again, here also similar to our variables, we have the three types of methods. Instance methods. Of course, few we have already seen. Class methods. Third one is static method. Okay. There are three types of methods we have for class. One is instance method, second one is class methods, third one is static method. Instance methods means when you are writing a method, when you are defining a method, you pass self as a parameter to the instance method. Okay, for instance methods, we will pass self as a parameter. So self. For class methods, we will pass the uh, parameter like class or CLS. And for static methods, we don't have to pass any parameter. Okay, let me write quick examples. The examples here, say for example, what type of method it is? M1. For M1 method, we are passing self as a parameter. For M2 method also, we are passing self as a parameter. When this method gets executed, self will be replaced with the object name for M1 or for M2 also. Okay, these types of methods are known as instance methods. Okay, object level methods. This we know. Okay, class methods we don't know. So let me write one example for class method. We'll add a new file, class method example. Let me take one class like this, say class demo, and I'll take one variable count equals to 0. One constructor I'll write. In the constructor, I'll say test.count, sorry, demo.count equals to demo.count plus 1. Okay, I'm trying to explain this with an example. Next, I'll write one method. Okay, I want to write one method. I want to make it as a class method. So define number of objects. This is my method, CLS. See here, automatically CLS is coming. Print number of objects, comma, demo.count. That's it. Let me create an object. T1 equals to demo, T2 equals to demo. And if I call this method like demo dot number of objects, it will print the number of objects. Okay, it's a very simple method. Okay, what is important to remember here? Okay, so I have declared one class demo. I have declared one variable, static variable, count equals to 0. Here I have written one constructor. In the constructor, I am incrementing the count value with the plus 1. Whenever a user creates an object, this count value will be incremented, plus 1 plus 1 plus 1. Okay, next, this is new to us. Here I have created one method and it's a class method. In the line number 6, if you see, I have mentioned at the rate class method, that is known as a decorator. Okay, so when you write at the rate class method just above the definition of any method, that method is known as a class method. For the class method, you have to pass the CLS as a parameter. CLS means class. Okay, uh, till now we have seen self, right? Self means object, CLS means class. When you want to use the state of the class, when you want to use the class variables or static variables in your method, we go with the class methods. Okay, here I want to use the class method count, so I'm just printing print number of objects, comma, demo dot count. So how to call this class method? Using the class name dot number of objects. So what would be the output for this program? So when I create t1 object, counter will become 1. When I create a t2 object, counter will become 2. Okay, class dot count value is 2. So when I call this method, number of objects 2 will be printed. Number of objects comma 2 will be printed. Here instead of using demo, you can say CLS also. Both will be same. CLS.count or class name.count. Both will work same. So if I run this program, class method example, see number of objects 2. Okay, this is an example for class method. So when you want to use all the static variables or class level variables in a method, you can declare one class method and you can use it. In order to declare a class method, you have to decorate with a class method keyword. Okay, that is about class method. Next, static method. Let me write one example for static method also. I'm not writing big examples just to make it simple. Static method. So it's very simple, same like a demo. We'll take one demo class, say at the rate static method. So define add a comma b. That's it. Print sum is a plus b. So if I want to use this, how can I use this? Like demo dot add of 10 comma 20. That's it. Okay. Same like class method, you can access the static methods also using the class name. What are the differences between static method and class method? In static method, we don't have to pass any class variable or self variable as a parameter. You can pass whatever is required for your computation. Okay, and if you don't want any parameters also, no need to pass any parameters. Okay, that's it. So when you require to perform some operations using the class variables, you have to declare the class method, and you can use the class methods using CLS object or CLS variable. Okay, and coming to the static method, when you don't want class variables or any static variables, you can go with the static method. Okay, the main purpose of the static method is uh, both but okay, both will work similar way. It's just convention based on your need. So based on your need, you can define the methods. Okay, coming to the static methods, generally static methods are used to create utility methods. Utility methods are helpful methods. In your project, you require some utility methods. Utility methods means you can create some number of methods. That methods can be used in different projects. They are common for all the projects. Okay, like some calculation you want to do, add calculation is a generic method, right? So in your project, for example, or in your organization, you are performing some string related operations. For example, your project will read some PDF files or docx files, in hundreds of files it will read. Okay, in those files, after a specific keyword, you want to get some value, or you want to split based on a specific word. That kind of utilities you want in your project, and that utilities will be used across the projects in your organization. In many organization, in many applications, you are going to use that. Okay, previously in my beginning days of my career, we worked for one company. So they used to give some PDF files. Okay, they will be having same format of PDF files. They used to write some invoices. Okay, so we can't read the PDF files and using any specific function. So what we did is, so they have given some format. Like if you have this keyword mmx, for example, this is some bill type 1. If you have mmy as a keyword, this is bill type 2. And in the bill also, So based on specific keywords, the fifth character is represents a company code. The sixth character represents the bill code. Like that, they have given some instructions. Okay, for that kind of operations, they are basically string operations only, but I want to use them multiple times. So when the fifth character is so and so, I want to mark it like a so and so bill, like that. So what we have created is we created one utility class, and we created some 50 to 17, between 50 70 methods, utility methods. We are using them. Okay, whenever you want to create any utility methods, okay, we don't go with the object or instance methods. We go with the static methods. Okay, the reason is simple. Let me tell you an example. Say for example, you have a utility method 1 you have. Okay, this one. If you create this one as a object method, okay, utility method 1 as an object method. Okay, this method you are going to use hundreds of times. Okay, more than 100 times, maybe 200 times you will be using this method. If it is a object based method, or if it is a instance based method, you have to create objects so many times. So many objects should be created. Okay, whenever you want to call that method, one object is required, and it will consume some memory. Okay, instead of doing this, if I create a static method, what happens is only one instance of the static method will be available for us, because we will have a number of objects, but we will have only one class, right? So only one instance of this one memory location will be available for this method if you declare as a static method. Even if you are using 100 times or 200 times, the memory consumption will be very, very, very less. Okay, based on this judgment, you have to take the decision. So if it is a utility method, you are going to use it 100 times or 200 times, more than that. So instead of creating so many objects in your program, you can simply declare it as a static method and you can use it. Okay, and in that method, if you want to use any static variables, if you want to use any class level variables, then you have to make it as a class method. Otherwise you can make it as a static method. Okay, as simple as that. Okay, when you want to do instance level methods only, when some methods are required only for the instances only, then you go for the instance level methods. Is it clear, or any questions? Let me know if you have
Sir,
any
I have a
questions.
question.
Yeah, go
Sir, I
ahead.
have a question, sir.
Yeah.
Sir, suppose if you declare a class level variable in static method and you cannot access it, sir.
Class level variables are can be accessed anywhere, right? So we can use them.
Anywhere, so we can use
Yeah.
them. Okay.
Mm. So with the class name and a class name dot a variable name, we can use it like that.
So, sir,
Okay.
we cannot access it by using object, right? This method, this static method.
Static methods can be used using the class names only.
Only class names. Okay, sir.
Yeah. Even if you are calling with object also, that is useless, because you are uh, unnecessarily declaring some more memory which is not needed. Okay.
Okay, sir.
Right. As part of class, we have one more concept called inner classes. Okay. So inside a class, we were seeing how to declare a variable and how to declare a method. We can declare classes also. Inside a class, you can declare a class also. That is also possible in Python. So inner class, say class 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 one. I'll say, for example, if you want any methods, you can declare those methods and all. Fine. Then if you want to have another class inside this one, you can create another class also. Okay, define maybe method one. Okay, print inner class method. Okay, this way also, if there is any requirement, you can declare class inside another class also. Okay, but if you want to access method 1 of a class 2, what you have to do, you have to create an object for class 1 and you have to create an object for class 2 also, then only you can access the m1. Okay, let me show you one example. So class 1, next c2 equals to c1 dot class 2. Again, I'm creating object for class 2, then c2 dot m1. This way I have to call this. Okay, so class 1 is the parent, I mean not parent class, outer class. Inside the outer class you have class 2 class, that is inner class. In the inner class you have the method m1. Okay, of course, the outer class can also have some methods. Maybe here you can have some methods also, maybe m2, that is also fine. Outer class method. Okay, if I want to access m2 method, how can I access? It's very simple, c1 dot m2. That's it. Okay, so these are like some convention things. When you want to have some dependency, like when you have object of class 1 only, then only you have to create the object for class 2. If there is any dependencies kind of thing, like when you have an object for engine, then only you have to create an object for the car class. Like that, if there is any rare situations, if there is any specific that kind of situations, then only we go and use for the inner classes. But in real time, we use very I never use in my 10-11 years of experience, uh, inner classes. I didn't get such kind of requirements to use. But just remember, we can declare a class inside another class also, that is possible. Okay, when do we do that? When you have a requirement like you need to have an object for the outer class, then only you have to create an object for inner class. If you want to create any such kind of dependency, then we go for the inner level classes. Okay, so can't we access the inner class directly, like class 2 dot? No, that is the rule, right? So when you want to create an object for the outer class, then only you have to create an object for the inner class. If you want to have that specific rule, then we go for the inner classes concept. Okay, just remember, as part of syllabus, keep this in mind as part of syllabus. So but if someone asks you in the interview also, I don't think they will stress you on this concept, because it is very lessly used concept. Okay, just keep in mind. So before going to inheritance, let me show you one more example, so we can jump on to inheritance concept. GC. Okay, in Python we have a concept called garbage collection. Okay, that means automatically when you are executing your programs, Python virtual machine will run one garbage collector in the background. So the job of a garbage collector is, if you are not using any object for a long time, it will remove the object related memory, um, object related space from the memory. Okay, so we don't have to write any destructor concept in Python. So automatically, when when a when a specific object is not in use, so using some algorithms, it will identify and it will destroy those identify objects. Okay, by default, when you are executing your program, your Python program, garbage collector is enabled. Garbage collector is always enabled, and that will be running in the background for your program. If there are any unused objects, it will be deleting them. Okay, so we can see that also. For that, we have to import one module. Import GC. GC means garbage collector. Okay, we can see like print GC dot is enabled. Okay, if you run this one, we can see is enabled is a method. It will tell you whether it is enabled or not. Okay, if I run this, it is saying true. By force, if you want to disable it for some any reason, you can do it. Okay, gc.disable. If you want to do that, yes, we can do that. We don't do this kind of things in real time, but this will be asked in the interview. For interview purpose, it is important. Okay, what is a garbage collector? They will ask you. Garbage collector is something which helps us to clear the garbage, we can say. Okay, clearing the garbage means if there are any unused objects in your program, that unused objects will be automatically deleted by the garbage collector. You don't have to write any destruction code, destruction methods, or you don't have to write any deletion code for the unused objects after a while. But for our practice purpose, we will be running the application and we will be closing it. But in real time, once one website is up and running, so that will be available, that will be executing your logic and everything for years together, right? If you open Gmail, Facebook, for example, they will be continuously running. So whenever a specific user is logging in, whenever a user is doing specific activity, so many objects, so many variables will be created in the background. So those should be automatically deleted. So that automatic deletion process will be taken care by the garbage collection. Okay, if you can explain up to this, that is fine. So point to remember is garbage collector is used to delete the unused objects, and this will be running in the background automatically. By default it is enabled. You don't have to do anything in Python. It is by default enabled. Up to that part, if you can tell them, it's good. Okay, so one more point here, if they want to trick you, so we have one more concept called a destructors in Python. Before before garbage collector deletes your object, if you want to execute some code, okay, some logic you want to execute before destruction of your object, you can do that. Okay, it's very simple. If you want to do that, you have to use one destructor method, that is known as delete method. Okay, let me write a separate program. You can refer destructor. The concepts, we were talking like inner classes, garbage collector and destructors. Keep them for your interview purpose. Okay, we use them very less in our real time day-to-day life, but for interview purpose they are important. Just keep that level of information with you. Okay, say I'll take one class. Say I'll write one constructor, print object created. Done. How to delete a destructor? Define underscore underscore delete. This is the destructor code. I can say closing connections. Okay, maybe you have created one database connectivity related object, or maybe you have created one big file operations related object. Okay, when automatically garbage collector is going to delete your object, before it's get deleted, you want to provide some disconnection, or you want to close some connections, you want to perform some operations, right? That kind of things you can do using the delete method. This delete method is nothing but your destruction method. Okay, even if you don't write this also, things will be working fine. But intentionally, if you want to do something before destruction, before deleting your object, if intentionally if you want to do something, then only this will come into the picture. Say I will declare one object for test. Okay, now I'll say t equals to none. When I say t equals to none, the object will become null, right? So let us see what happens. Run this program. See, object created after line number 8's execution. When line number 8 is executed, it will call the constructor, so object created will be printed. Next, when line number 9, what I'm doing, t equals to none, I'm nullifying the object. I am deleting the object intentionally in the program. But generally we don't, we may not do directly this way, but in the background garbage collector may do it if you are not using that object frequently. Okay, so see here, before nullifying, before deleting the object, so it is executing the destructor method. If you want to do this kind of things, you can do it. Okay, keep them like for your, what I can say, for your interview purpose and all. So let's go to the next topic, an important topic, inheritance. So I'm very keen about these parts. I'm sorry guys. Like how to declare a class, how to declare variables, how to define an object, what types of variables we can write, what types of methods we can write. These are very important things, and they are like our day-to-day life activities in our programming life. Okay. Next concept of OOPS is inheritance. What is inheritance? Or I can say acquiring the properties of a class into another class. Okay, acquiring the properties. When I say properties, of course, both methods and members and member functions, both acquiring the properties of a class into another class is nothing but inheritance. Like how we are inherited from our parents, like we will get some properties from our parents, right? Maybe assets, maybe some genetical properties, the body language, so many things. In the same way, we can acquire the properties of one class into another class. That is also possible. So what is the advantage of this one? Advantage of this one is reusability, actually. Reusability. You have written one class which is very much sophisticated, which is having so many good functions. uh, you want to use them in another class. Instead of rewriting all the functionalities in another class, what you can do is you can do inheritance. You can extend, or you can inherit the class 1 into class 2, and you can use them. Okay, there are two things we need to understand when we are talking about inheritance. Like has a relationship and is a relationship. Has a relation, is a relation. Okay, has a relation means we will use the object of one class into another class. Okay, that is a has a relationship. Is a relationship means we will extend one class into another class. Okay, so let me show you an example so that you can better understand this concept. Let me write one example for has a relationship. Okay, so it's very simple, so you will understand very easily by seeing the program. So maybe has a relation. I'll write a class engine, and some variable I'll take a equals to 10. I'll take one constructor in it. Say we'll say some properties here. I'll take one more method. Print engine function. Okay, I have I have one class engine. In this one I have a variable, static variable a equals to 10. I have a constructor, and in the constructor I have one instance variable b equals to 20. I have a instance method m1. Okay, so in the m1 I'm just printing engine related function. That's it. Okay, I'll take another class, maybe car. In the car, what I'll do is I'll write one constructor. In this constructor, I will take object of engine. See here. Here generally we can write the variables here, right? Self dot b means one variable b will be declared and its value will be 20, right? In the car constructor, what I'm doing here is just like b, I'm creating an object of the engine class. I'm creating an object for the engine class. Once this object is available here, I can use the properties of engine inside this one. Okay. Say for example, I'll write one more method here. Define m2. Okay. Here I'll say print self dot engine dot a. Okay. Print self dot engine dot b. Of course, I can call this m1 method also. Self dot engine dot m1 method. Right. So now outside of these two classes, what I can do is I'll create a object for car. I'll call the c dot m2. Okay. So now what happens? This is an example for has a relationship. Okay. What is having what car is having? Car is having engine class. This is has a relationship. So if you don't understand this part, I'm just repeating. I declared one class called car. In this car, I am defining one object like self dot engine equals to engine. For engine class, I am declaring one object here. Okay, and I have a one instance method m2. In the instance method m2, I am using the properties of engine class. I'm using the properties of engine class. What are those properties? I have a property a, variable b I have, and m1 method I have. Three properties I have here, and all those three properties I'm using here. It is not mandatory to use everything. On need basis I'll be using them. So here the print self dot engine dot a, I'm printing the a value. Self dot engine dot b, I'm printing the b value. And self dot engine dot m1. Okay, so I'm calling the m1 method. This is m1 method. Okay, so this is what I have written here. In the line number 15, I'm declaring an object for the car class. C equals to car class. So for this class, one object C will be created. When object C is created, what happens? The constructor of the car will be executed. The constructor of the car will be executed. In the constructor, what I did? Self dot engine equals to engine. That means self means the C here. C dot engine equals to object of engine. Okay, this will be created. Next, line number 16. C dot m2. I'm calling this method. Okay, what happens here? It will come here, print self dot engine dot a. Self dot engine dot a means c dot engine dot a. C dot engine dot a means it refers to value 10. Again, c dot engine dot b, 20 will be printed. C dot engine dot m1 method, I'm calling this method, so that will be printed here. So if I run this program, we got all the values 10, 20, 30. If you see in this example, we are acquiring the properties and functions of engine class into car class. We are acquiring the properties of engine class into car class. So this concept is known as a inheritance concept. And this particular to inheritance concept, this is known as a has a relationship. The car the car class has engine class, so has a relationship. Okay, so any questions about this part? This is
Hello, sir.
important, guys. Yeah, go ahead, please.
Sir, sir, in this class car, we are storing the whole engine class in this self dot engine, right?
Yes,
Like indirectly, like what I meant to say.
yes.
But sir, that self dot engine is like an object, right? So this whole class will be indirectly stored in an object called C, right?
Self.engine, self is the
It's like
object for
mm,
car class, and
uh,
again for self you are declaring another object. Engine is another object again. This object is for engine class. For engine class, like how you declare a object here, C equals to car. In the same way, engine equals to engine. Like this, you created an object, and this is like a variable for this class, car class.
okay.
Go ahead if you have any other clarifications required. Simply, we can create an object for one class in another class constructor. We can use all the functionalities of the class inherited in the another class. So simply, engine class object is created inside the constructor of the car class. Here I can use all the properties of engine instead of rewriting. So for example, m1 is a beautiful functionality. Okay, some useful functionality I have written. Instead of rewriting the m1 code here again, but for our basic understanding, we will write only print statements or simple statements only. But in real time, we will be having so many lines of code, so many complex logics. Instead of rewriting this again here, I can reuse it, right? Already it is existing here, so I can reuse it. How can I reuse it? So simply by calling it. Okay, inheritance, the purpose of the inheritance is reusability. Any other questions about this example? If you are okay, I'll go to the next part. That is more important part, easier relationship part.
Sir, maybe it's a silly question or something. I have a question, sir.
No problem. Yeah, no problem.
Sir, when you have a class car where we have given self dot engine, right? When we are trying to call the car at C is equal to car, but what's the
Mhm.
result which we are getting out of that?
You're talking about line number 16?
Yes, sir. What's the result we are getting out of line number 16?
Result, what do you mean by result actually?
నేను తెలుగులో చెప్తాను సార్. ఇప్పుడు మనము సి కార్ లో
Yeah.
సెల్ఫ్ డాట్ ఇంజిన్ అని ఇంజిన్ కాల్ చేసినప్పుడు మీన్స్ ఐఎమ్ టాకింగ్ అబౌట్ 8, 9 అండ్ 10. సో ఈ పార్ట్ లో మనకి ఏమేమి తీసుకుంటుంది సెల్ఫ్ డాట్ ఇంజిన్ నుండి? వాట్ ఈస్
Okay,
ఇట్
good.
కలెక్టింగ్ అవుట్ ఆఫ్ ఇట్? అంటే ఏ ఈజ్ ఈక్వల్ టు బి, ఏ ఈజ్ ఈక్వల్ టు 10, బి ఈజ్ ఈక్వల్ టు 20 అని కలెక్ట్ చేసుకుంటుందా ఆ పార్ట్ లో? వాట్ ఇట్ ఈస్ టేకింగ్ అవుట్ ఆఫ్ దాట్?
Okay. Okay. Say for example, if I write like this, self C equals to 20. Okay. You don't have any questions about line number 16, right? In this scenario,
నో
like
సార్.
C. Okay, C, for I'm creating an object C for class car. So in the constructor, I'm saying self dot C equals to 20. What happens here? In the memory, one variable C will be created under, I mean, not C here. Say for example, I'll give a different name, D for example. Okay, I don't want to confuse with same names. So D, one variable will be declared inside C object, and its value is 20. Okay, this is clear to everyone, I think. So in the memory, say one block for object C is created. This is object C. Inside object C, I have a variable. This variable name is D. Variable name is D, and its value is 20. Okay, 20 only I have given, right? So whatever the value I have given here, okay, 20. So we don't have any problem with this example, right? Now we'll come to our example. Here, engine equals to engine. Okay, what happens now when line number 16 gets executed? Okay, forget about this one. I have one object C will be created. This is object C. Okay, inside object C, the constructor will be called. In the constructor, what I'm doing here, I'm saying self dot engine equals to engine. So what happens here is like how you got a d equals to 20 here, I'll get an object here. Okay, its object name is engine. Its object name is engine. Okay, I got a object engine. Same like how you got d equals to 20, I got engine equals to engine here. Fine, good. Whenever I'm creating an object, same like c equals to car, it is same, right? Engine equals to engine. Here, whatever the variable I'm taking in the left hand side, that's fine. Engine equals to engine means I'm declaring one object for engine class. Whenever we are declaring an object for engine class, what happens? The constructor will be called. In the constructor, what I have written here, self dot b equals to 20. Here self means engine. Here I'll get one more variable, b equals to 20. This is b variable and its value is 20. When I executed line number 16, c equals to car, this is what happens in the memory. Okay, is it clear?
Yes, sir.
Okay, also I have a equals to 10, I have one method. These two will also be available as per engine class and as per engine object also. For both they will be available. The reason is a is a static variable. Static variable we can call using the method. I mean we can call using the class name and we can call using the uh, object name also. So this will come to us. So it will also come. So line number 2 to line number 15 means you have to understand this way. Inside one class, car class, you have another class, engine class. So using C object, you can use entire C related properties and methods, engine related properties and methods also you can use using the C. Okay, is it clear or still anyone is having any doubts? Please let me know if you have any questions. This is important, guys. I don't mind even if you don't talk too much about delete, destructor, function, or inner classes. I don't mind because they will be rarely used concepts. This is important because this kind of things we use in our daily life of programming. We have to use inheritance concept and all.
Sir, hello, sir.
Yeah, go ahead.
Sir, sir, in the line number 10th, that in the right hand side, we give engine, right? Engine brackets, the parenthesis. So, sir, it means
Yeah.
that everything will be copied, right? So, including the methods, everything, whatever in the class here, everything will be copied to self.engine, right?
Yes.
Okay.
Yes. Everything. So the name itself says it has a relationship. Car has engine. So remember like it's a physical car. Remember like it is a real engine. Inside car, you have a real engine, right? Whatever is available in the engine, everything is available in the car also. Same way you have to think. So everything like A equals to 10, B equals to 20, M1, everything is available in engine. They are all available in car also. That way you have to think. Clear?
Yes, sir.
Okay. Let's go to the next one is easier relationship. This is important. There are so many types we need to understand as part of easier relationship. Okay, today I'll tell you only one simple example and we'll close the session. There are some different types of inheritances available for us as part of easier relationship. We'll discuss tomorrow. Okay, so is a relation. It's very simple. In this concept, we will have parent and child relation. Okay, so for example, I'll take a class parent. Here you can provide any name. I'll define one method. Okay, Done. Print parent class method. Okay. If anyone is coming from any other programming language background, I'm sure they have come through this kind of thing. Next, class child. I want to inherit parent class into child class. I want to use all the properties available in the parent class into the child class. How can I do that? It's very simple. I have to say child of parent. Child extends parent. We call it as a extension. Extends. So here I'll define one more method, m2 instance method, print child class method. This is the concept of has a like easier relationship. Okay, acquiring properties of parent class into child class is known as the inheritance. Okay, this is known as parent class. This is known as a base class also. Okay, the second one is known as a child class or derived class. You can call it as a derived class or child class. This is known as a parent class or base class. Some people call parent class as a super class also. In Java, they call it as a super class. Now, if I create an object for child class, C equals to child. What are all available for C? C dot, see here, M1 is available and M2 is also available. I can call M1 C dot M2. That's it. This is an example for simple inheritance. Let me run this. I'll get the output for both the methods, parent class method and child class method. Here we need to understand a few more things, how the constructors will be working in the, like how I can call the constructors from one inherited class to another class, like that. There are some combinations. I'll show you different examples. We can understand in depth about this concept. Okay. Do you have any difficulty in understanding this program? The program what is available on the screen? So parent class will have some XYZ methods and variables. Okay. If you want to use it in another class, so you can declare another class, child class. In the parentheses, you have to provide the parent class name. So what happens here? Actually, child class contains what? If someone asks you, it contains all the classes and all the methods and properties available in the child class plus all the classes and all the methods and properties available in the parent class. Both the things it will contain. Okay, you can think in another way. Child class is an extension of the parent class. It is an extension of the parent class. It will contain everything which is available in the parent, plus in addition to that, it will have some extra methods. It will have some extra variables also. So child class is an extension of the parent class. So okay, this is an example for easier relationship. There are some different types of inheritances we need to understand, like a single inheritance we have, multiple inheritance we have, multi-level inheritance, hierarchical inheritance. There are different types of inheritances. It will take one more class, so we'll continue the session tomorrow. We'll cover all the types tomorrow, and we'll see some different examples, like what if I'm calling only constructor of the parent from child class? What happens? Um, how we can call? We'll try different combinations tomorrow. Okay. If you are clear so far, we'll conclude for today. We'll catch up tomorrow. Any questions on this part? Hope this is straightforward. We'll
Sir,
see
I have a question.
some. Yeah, go ahead.
Sir, if you want to acquire one property from parent class, we will use has a relationship, sir. We have to use only has a relationship.
One property,
Only
not one property. We'll get not only one property. We'll get all the properties.
But particularly for one property, what we have to use, sir?
Okay, when you want to get only one property. Okay, combinations we'll discuss. Okay, give me some time. We'll discuss different combinations. Like I want to get only few properties. How can I get that? So what's the main core difference between has a relationship and is a relationship? We'll discuss. Okay, once we cover this part, you can understand that. Okay, give me some
Okay,
time.
sir. Okay.
As compared to has a relationship, in easier relationship, we don't need to create an object, right? Yes, yes. Ganesh, you're correct. So
So almost
sure,
both are like
Priyanka.
same, sir.
Yeah, both are like same. Give me some time, guys. We'll show you some more examples so that you can better understand the differences between easy and has a, and what are the different uh, types of inheritances we have. We'll see some combinations. Okay, in the next class. So different combinations, if you see, and different outputs you, if you are experiencing, you will get more clarity if you have any questions still. Okay. Yeah, examples I'll give, Priyanka. Sure, definitely I'll give examples. So I'll make sure you understand the concept very well uh, with more clarity. Then only I'll move to the next topic. Okay. Today consider like it is an introduction for inheritance concept for you. So we'll see more examples tomorrow. Okay, guys. I'd like to conclude for today. We'll catch up tomorrow. Is Prashant available?